So how do we find the degrees of freedom for these chi-square tests? Well, this is the goodness of fit test. So there's only one. So it's a one-way table really, because there's only one set of categories. Okay, so it's like this. So that's the way they word it here. Well, the goodness of fit is the key word. So when you have to find the degrees of freedom for a goodness of fit test, because we only have one set of categories, we have n categories, and to do the degrees of freedom, we do n minus 1. That's the same for t-distributions, for a standard deviation, et cetera, et cetera. So since they're telling me there's 3 categories, 3 minus 1 tells me there's 2 degrees of freedom. The 89 just tells me how many different subjects there are. If I add up all the numbers, all the people, actually there's only 3 categories. So across these 3 categories, whatever they are, there's a sum of 89 subjects, which isn't part of this question. Okay, so goodness of fit, degrees of freedom, you do n minus 1. Number of categories, minus 1. Now, what if you're doing a two-way table? That's down like question 9. Let me clear this out. So when you have a contingency table or a two-way table, what you do to get the degrees of freedom, you do the number of rows minus 1 times the number of columns minus 1. So since they told me there's 8 categories in the column and 6 categories in the row, so that will be 6 minus 1 times 8 minus 1, which is 5 times 7, which is 35 degrees of freedom. Okay, next let's see if I get this right. I didn't check for the other one because I knew I did, but see, so that's how you do the rows. That's how you do the degrees of freedom for the 2 kinds of chi-square tests that we're going to do this week. Hope that helps.